So, so today's topic is on the interactive data science. This is the topic is dear to my heart. So, at the Open Data Labs, we also try to working for interactive data scientists with interactive analytics and interactive visualization as well. Earlier this year, on one of the dinner parties at Microsoft, I met Professor Perez, and so I invite him to see whether himself or one of the team members can give a talk on the IPython-notebook or Jupyter projects and see how where's the status that, and because we will try to see whether we can integrate with it. So Professor Perez, you recommended Min Ragan-Kelley to give these presentations, and so we're very happy this has finally happened. I know they are very busy in the last few months, and so this is we're so glad that he could be here to give this presentation. So Min has been core contributors to IPython since 2006. And after he got his PhD in UC Berkeley in 2013, has been full-time contributing to this project. And he's also maintainer of the Python language bindings for the ZeroMQ. So he has spent a lot of time on this project. So with that, and we'll welcome Min to give this talk.
Hi. Hello. As you said, I'm Min, and I've been working on IPython for a long time. But for the first several years of my contributions, they were typical volunteer open source contributions, and then the traditional dissertation procrastination contributions. And then I finally graduated and got to have my procrastination become my full-time job, which was kind of an ideal situation. And I'm going to talk a bit about how kind of what's going on in IPython and Jupyter, and how we use these tools to do interactive data science, and the various deployment opportunities we've had for using IPython and Jupyter in different ways. And I'll talk a bit about kind of what it is and how it works to get started. Before I start doing that, just a quick poll, because I have to gauge these things. How many people use IPython-notebook? Well, that's pretty good. And how many know what it is? Okay. So some of this will be maybe a little redundant for a few of you. But so I'm going to talk about kind of how do we do data science, and kind of do it in a few steps. We write some code, we run some code, we visualize some results, and maybe do a write-up for communication. Then we share what we've done and reproduce what other people have done, and kind of you think of it as maybe in a nice linear order, but in reality, it's much more of an iterative process where at every step you realize you need to go back and go back to 1 or go back to 3 and do it differently, and you keep doing it over and over and over and over again. And there are lots of tools for these different stages. IPython is a tool basically for this loop of writing and running code. IPython helps you run code by providing little things to make interactive execution just a little bit nicer. Gives you things like nice tab completion to kind of poke around the objects, introspection to see signatures. With question mark or with 2 question marks, you can see the source code of methods and functions. And then in addition to the Python language, we add these magics that let you do kind of shellish things like ls and cd, and timing, kind of the common things that are inconvenient to type in Python, but you might want to do relatively frequently. We extend the Python syntax with what is not valid Python, but makes some of these tasks simpler. So IPython's about helping you run your code and get that iterative process of figuring out what code it is that you actually want to write, help you make that more efficient. Over time, we've become a little bit more ambitious with our goals, and Jupyter has little bits for all of these steps. So some people can be a bit confused about the relationship of IPython and Jupyter. And so Jupyter is kind of a descendant of IPython. IPython started out as just a simple better interactive shell for Python, right? As interactive Python. And as we were working, we thought about new interfaces, new models for doing interactive computing. And eventually we had this web notebook still as part of IPython, and IPython had grown to be a rather large project. And we've decided that several pieces of that project are going to move under a new name that are language agnostic and not about Python anymore, but it's starting out as the same code and it's just evolving under a new name. So what really is Jupyter? Well, for one thing, Jupyter is a protocol for a rich REPL, read, eval, print loop. So we have this notion of a kernel, which is where your code runs, and it has these ZeroMQ sockets of various sorts. And a client connects to the kernel and sends JSON encoded messages over ZeroMQ. And you can connect multiple clients to one kernel. So you can have 2 users and 2 UIs, or 1 user and 2 or 3 UIs connecting to the same kernel. So there are some things that the notebook is better at. There are some things that a terminal console is better at. You can have the same runtime process where you're working in both of those interfaces at the same time. So you can open your notebook and then you realize, for quick interactive stuff, maybe I want to have my maximum read line foo feedback, and you can be using both of those interfaces at the same time. And you can also connect small services to just monitor, say, you can hook up monitor services to the kernels to just see what code is being executed, log the results that are coming out of the kernel without having the clients participate. Jupyter is also a document format. So we have this notebook document that has code, math, prose, input, and output all in one document. So that REPL over JSON and ZeroMQ, you've got the read stage. So we've got a message to request code to execute. You send that to the kernel. Then the kernel runs that code. It's the eval step, and the kernel sends a reply saying, this is the result of that execution, or this is the error that was raised. And then print, which gets a bit of an asterisk because instead of printing to a terminal, since we're talking to web UIs and things, the display data can be HTML, text, images, and iterate over that. So the big step beyond a terminal REPL in the Jupyter protocol is all in the P part, right? So you have any MIME type. You can have an example of, you can have text output. You can have SVG, PNGs, JPEGs for your plots or for any other graphics. You can have LaTeX for mathematical representations. If you're doing math, and you can also have HTML and JavaScript for everything from simple tables to complex interactive JavaScript-based visualizations. And then finally, you have interactive widgets for building a result, but that result is itself something that you can interact with and compute new results. So this protocol is actually, we built this protocol in order to separate execution over the network, but we were still thinking we're still building IPython, so we just want, we're just abstracting a Python REPL over the network. And then after about a year or so of doing that, we kind of realized there's actually nothing Python specific about the protocol that we're building. So we ended up getting, over time, different language communities, like the Julia community, which is an interesting language for numerical computing, and the R community, which is used in statistics, and then over time, a number of kernels. We now have about, I think last I checked, 43 kernels for Jupyter, and the cool thing about this is that the Jupyter team has not written the vast majority of these. That we wrote the protocol, we published the protocol and said, hey, if you want to use the notebook in your language, you can just implement this protocol, implement the kernel side of this protocol, and then you get all the notebook stuff for free, and you don't need to build UI and all this stuff. And several language communities have adopted that, which has been exciting and has validated a lot of the work that we've done. In fact, a couple weeks ago, I wrote a toy C++ kernel for if you want to do interactive C++ in the notebook, which I hope nobody does. Although I did get contacted by someone who wants to teach with it, which is slightly worrying. So in the notebook, you have what is the notebook document? The model that we have is a notebook is a sequence of cells. A text cell is Markdown and Markdown for rich text and LaTeX for math. A code cell is one of these read, eval, print, whatever you call one iteration of the read, eval, print loop. And the key of that is that the cell actually contains both the input, both the code that you run, like a script, but also the cell itself contains the output. When you run it, it captures it, and the output of running the cell is becomes part of the cell. And then we also have metadata everywhere for adding little bits of information to the document for when working in different contexts. The notebook document format is a plain text JSON format. It's a publicly documented schema so that you can easily work with notebook documents without using our NB format code. It's a very, very simple format that you could, even though we do have a schema, it's extremely easy to just look at a JSON file and kind of see how it works. And because we store enough information in the document, you can take the JSON and transform it into a variety of other formats for consumption or in a variety of ways. And we have a tool for doing that called NB-convert. But the notebook's not just a document, it's also the environment, the interactive environment where you're building the document. And the notebook can also be an input format where you build a notebook, and then that notebook can be an input to, it can represent a pipeline in a computation. It can be an input to a publishing tool. It can also be an output format. Like you could be writing scripts, doing batch processing, and then in the end, you actually build a notebook as an automatically constructed report of what you've done, and then the report itself, being a notebook, is actually something that people can take and interact with and modify. And so some applications of notebooks that we have NB-convert, which converts notebooks from two other formats such as restructured text, HTML, LaTeX, PDF, Markdown. Convert a notebook to a plain Python script. You can make presentations with Reveal.js. NB Viewer is an online service that is just, all it is a web service that wraps NB-convert to HTML. And you give it a URL, it downloads it to a notebook that's somewhere on the internet. It downloads that notebook, converts it to HTML, and gives you a page. And that means that you can share, if you have your notebooks that are JSON files, you can share them, you can show them to people who all they have is a browser by you put your notebook somewhere on the web, and then you point them to NB Viewer, and NB Viewer will render it to HTML. And recently, GitHub started rendering notebooks to HTML just in the browsing. So if you see a notebook on GitHub, rather than seeing some JSON blob, you'll actually see the rendered HTML notebook, which is an exciting development. NB Grader is a tool that Jess Hamrick at UC Berkeley has worked on with Brian Granger at Cal Poly for doing automated grading and assignment distribution for a class of roughly 220 students in computational modeling of cognition in psychology. And with NB Viewer, taking advantage of the metadata on a notebook that I talked about earlier, she can mark up cells as this cell is this is a cell I should grade. This is a cell that contains this contains an answer to a question. So it works with prose answers. It doesn't auto-grade prose, but it can mark those as things that should be graded, and it provides both automatic grading for checking with tests with assert statements, and then manual overrides for giving partial credit and grading prose, and then putting all that in grading databases, and it has really made the process of staying on top of grading programming assignments for hundreds of students manageable by a small number of TAs. Run IPy is a tool for taking notebooks and treating them as scripts. So you have a notebook, and you can provide input to that notebook, run it, and then you produce a new notebook that actually has updated output, possibly with new inputs. That most of the run IPy functionality is now a part of NB-convert with an execute flag. So NB-convert can now, when converting notebooks to HTML or other formats, it can actually do a fresh execution of all of that to provide fresh reports, make sure everything's up to date, or even just as a sanity, a testing mechanism to make sure that this notebook is still valid. Sage Math Cloud is a hosted service that is significantly more than notebooks. It hosts terminals and files and all kinds of things, but among the things that Sage Math Cloud hosts is notebooks. And one of the cool things that Sage provides on top of what the vanilla notebook server does is live collaboration. So you can actually have two users pointing at a notebook and see each other typing Google Docs style, which is something that we're also working on in the vanilla notebook server, but we're not there yet. TempNB is a service for hosted ephemeral notebooks. So you spin up a small server, and then you can point users at it, and then when a user hits the server, they get an anonymous notebook server in a Docker container just for them, and then when they leave, that Docker container gets destroyed. So you can so that the resource consumption is minimal. Dexy is a document workflow tool that treats notebooks more as an output product, where it's a tool for weaving together lots of different kinds of documents and building documents of different classes and running code and stitching outputs together in a variety of ways. Jupyter Hub is a project that I'm strongly involved with, which is a multi-user notebook server, which is what Jess Hamrick used for her class. So she ran a Jupyter Hub server hosting notebooks for all her students. That all ran on Rackspace using Docker Swarm. Phoebe is another exciting new development from OReilly, which is taking that Jupyter protocol to run code and take input, run code, and get output without the notebook. So you can, with Phoebe, have a web page with code snippets that people can play with, and you don't have to buy into the whole notebook model to have little snippets of code and examples on your website that people can play with to, say, test an API or something like that. So now I'm going to switch over to the notebook to demo a few things. And I will start begin mirroring so that I see what you see now. All right, so this is actually the notebook. So the basics are, I've got interactive code. I can make new cells. I can type things, run things. It's running just locally on my laptop. I've got the magics to do things that aren't Python. This is a NumPy polynomial object, which it's hard to represent a polynomial equation nicely in ASCII. But when we're in the context of the notebook, given a polynomial, I know how to write that as a mathematical equation. So given the parameters of a polynomial, I can display that as LaTeX, and then I get a nice polynomial in terms of x, and it shows me the domain. So being in the notebook lets you have, you can have just the representation of your object when hit with the display hook can actually be an arbitrarily complex interactive representation. So you can have a big example of this is the pandas library for tabular data and series data represents its object as HTML tables, which is a lot nicer than trying to ASCII format tables that you get in the terminal. Further interaction, you get these interactive widgets. So I have a function that factors x to the n minus 1 with SymPy, and SymPy is a library that actually provides this LaTeX representation by default when you're in. So the SymPy library itself provides representations of all its objects as LaTeX that IPython can use. So now I've got x to the n, and I can just move this slider, and when I move it, it solves the equation again, and then displays the new solution to every value of n. I can make things. And these widgets, that we got widgets for a variety of basic input forms, simple integers, floating point numbers, toggle checkboxes for toggle switches, and then text boxes. So you can use these things to explore, if you've got a function you want to find, you've got some parameter search you want to do for your data munging or filtering or cleaning, you can, and you want to do some kind of bandpass on your data to trim out, trim some outliers, but you don't know exactly where you want to trim that. You can actually write your function that, does some visualization of the data that trims at a variable, and you can just take a slider and say, okay, what does it look like, to slide this boundary around, and just play around visually and interactively, see kind of what the best value for that is. And this is part of the goals of IPython in general. There really are, most of the time when we're writing code, at least for us, because the folks who work on IPython, we're all scientists by training. We're not programmers. We were working on IPython because we wanted to use it for me, it's plasma physics. For Fernando, who started the project, it was quantum chemistry and particle physics. For Brian Granger, it's atomic physics, and for Thomas Glauber, it's plant biology, and we wanted to use Python, but a lot of the time when we're writing code, we don't necessarily know what we want to do. Right? We know vaguely, I want to use pandas for this. I want to use NumPy for this. I know I want to do this kind of convolution, but I don't know exactly how I want to do it. So you spend a lot of time kind of poking around. And that's what a lot of the interface decisions in the notebook are targeted at. We've got prose and math. Here I've got my Markdown cell with a bunch of, I'm a physicist, so of course it's Maxwell's equations. And this, with having inline with the math and the code and the plots and everything, I can have, for instance, this mathematical identity that e to the I omega t is equal to cosine plus I sine. I can illustrate that identity by plotting those four components, basically the real and imaginary parts of the left-hand side, and then the real imaginary parts of the right-hand side. And if I plot those, I can see that, okay, the left-hand side, which is the lines, and the right-hand side, which is the dots, they really do line up, and they're not sensitive to what omega is. And I can just quickly kind of show, not just show with math, but I can show graphically, what the consequences of the math are, and it lets you put right next to each other, whether it's your math that's explaining your code, if you're trying to explain your model, or if it's your code that's explaining your math, if you're in an educational context. Having them next to each other and being able to interact with them back and forth makes it kind kind of enables that communication for the people who maybe learn better visually or learn better with reading the words. You can have all of those things next to each other and kind of talking to each other and benefit each other. So when you're actually doing data science, since I don't know, so I sit some of my days in the Berkeley Institute for Data Science, and one of the things that we're working on is figuring out what the hell data science means. That it's an ill-defined field, and a lot of what we do when we're doing data science is just trying to figure out what stuff means. Like I've got information and I know there's meaning in it, but I don't necessarily know how to extract that significance out of my big blob of data. So we spend a lot of time. Okay, I've got my data, I've loaded my data, and then kind of now what? And this is I've just generated a random a bit of data into a pandas data frame, and this is an example of pandas, which represents itself as nice nice HTML tables. And I can, all right, I want to summarize my data. Okay, what are the means of my columns? Maybe I want to plot it, but I don't remember how to plot with pandas. It's got lots of parameters. Okay, use question marks. Say, what are those parameters? Okay, I can specify an X. I can do different kinds of plots. I can do bar plots, line plots. I can sort the columns or not. I can set X limbs and set log things. And okay, so now I can look through that and then say, okay, well, default plot's fine. Okay, there's my line plot of random cumulative sum, which is roughly equivalent to the stock market, which is just random. And okay, well, that's really, say I've got some noisy data and I want to smooth it out to see trends. Well, maybe I know how to do smoothing with a convolution, so I can write out my convolution to smooth over a window of 11 points, to kind of take a bit of the noise out of the signal. Then someone told me that maybe pandas can do this for me, because that's usually, if you ask, how do I do this with pandas, and then the answer is usually there's a method for that. So I can tab complete on pandas and kind of looking through. It's like, okay, well, these look kind of interesting. Rolling mean. What does rolling mean do? Okay, rolling mean is a sliding window mean, which is in fact exactly what I had implemented with my NumPy convolution, but now I can just call a pandas method to do it, and I'll stick interact on it, because let's say if I'm smoothing out the noise, maybe I don't actually know what my window size that I want to use. Well, there's a window of 25, there's a window of 2, that's still a little too noisy. Window 49, maybe that's too smooth, I'm losing information. I'm going to slide it around and figure out what kind of value actually gets me the kind of smoothness that I want. This is kind of a common pattern that we see in a lot of people's work, that they know they want to do a certain kind of thing, but there are a collection of parameters when they just have no idea what the right, maybe they know ballpark, but they just don't know what the right value for those parameters is going to be, or maybe they've got a variety of algorithms and things to apply, and you can key those by name and say, pick from a drop down. Say, see what this algorithm has to say about the results, and see what that algorithm has to say, and compare and contrast. So the second stage that we see notebooks doing. So there's notebooks as the interactive environment, where we're really poking around, exploring, figuring out what it is that we want to do. And then once you've kind of come up with something interesting, then you've probably got a notebook that's a bit of a mess, but at least has all your work in there. Then, okay, you found some interesting result. You can still with a notebook, either with a new notebook or in the same one, say, all right, now I want to prepare this result, this analysis for public consumption, whether it's a report to a different department in your company, or a blog post, or a scientific publication. You want to communicate this result to somebody. Then you can use all the Markdown cells to write prose descriptions of what you're doing, mathematical representations and validations of your models, clean up your code, whatever it is you feel like you need to do to communicate. And then you take that notebook and you can either provide that notebook as the raw notebook itself to other IPython users, or you can take that notebook and convert it to a different form for consumption in other media. So some successes we've had with a notebook in science. We've had a few publications, actually a number of publications now, where notebooks are included as kind of computational companions for reproducible research. So this is the analysis we did, and people provide a notebook and an AMI or a notebook and a Docker file or something, and for rerunning the analysis and seeing the visualization and seeing actually everything that they did to produce the scientific results in that paper. We've also had some success with people using the notebook to blog. So Jake Vanderplas is an astronomer at the University of Washington, and he blogs about various scientific Python topics. And the way he does it is he has a Pelican blog hosted on GitHub, and all his blog posts are just notebooks. So this blog post is a notebook that has various Python code. Maybe let's go to his hipster one. That's a fun one. So this is a mathematical model for the hipster effect of reacting to popularity by switching your opinion. And it's a bunch of math showing for various parameters, showing the divergence or convergence of hipsters and conformists, depending on the strength of the hipster effect. And all of this is done with, because he's an astrophysicist, he uses math, he uses prose, and he uses Python to explore concepts, and then publishes these with Pelican. But he puts them all together in the notebook. Peter Norvig, the director of research at Google, is also someone who does explores concepts in the notebook. So he is usually So right now, Rackspace generously provides hosting for NBViewer and a variety of our services. Before that, we were using free instances on Heroku, and Peter Norvig would frequently destroy our Heroku instances with his blog posts because he is significantly more visible than any of us, especially when he decided to write about XKCD. That brought a variety of corners of the internet together to bring down our modest hardware. So he's written about an exploration of the traveling salesman problem, all with an IPython notebook, and it's a wonderful explanation that really goes in detail about. He has a lot of good write-ups of ways of solving problems that people may have seen. His regular expression golf notebooks and some other good explorations. And what he does is he just writes a notebook, puts it on his website, and then links to NBViewer. So this is just NBViewer on IPython, and then you give it a URL, and this is where the raw notebook is. And then Nicola is another, like Pelican. Nicola is a static site generator blog platform that supports notebooks. There have been a couple books, Signal Processing and Bayesian Methods for Hackers, that are in fact written entirely as IPython notebooks. So this is also on NBViewer. This is an entire textbook on Bayesian statistics and programming Bayesian statistics in Python. This is also just an NBViewer page, so he just put his notebooks on the web, and You just point NBViewer at his GitHub repo, and then you can read through essentially a full academic textbook on statistical modeling. And then we've also had Scientific American, 538, and the New York Times graphics team all using IPython notebooks in various capacities for either doing reproducible things, for sharing their data, and then most recently, OReilly with their Thebe project. So I don't know if you've seen the beta, but OReilly's calling their their beta platform. So this is also by Jake Vanderplas, the UW astronomer. This is a post on OReilly with OReilly's Atlas publication stuff, and it has little code snippets that you can run. You can step through. And this is specifically not a notebook. Like, there's no Markdown here. This is just a regular page, but the code is still interactive. And I can still edit the code. We can. I can still change the code and rerun it, and it's still fully interactive. And the quickest way to get to the bottom is do this. And so this is a way of having not a notebook, not the full notebook environment, but interactive code snippets that are illustrating the topic that you're writing about. But actually, all you're reusing is just the kernel, just the execution piece. And so once you've got your, your kind of ready for distribution form of the notebook, then you can export it with NB-convert. So if I in this case convert the notebook that I'm looking at right now, I can go convert it to Markdown and then peek at the top of that file. You can see I've got a Markdown cell, code cells just got indented. And all these templates are all fully customizable, so you can have arbitrarily complex templates for exporting and working with your blogging engine or publication pipeline. And then I can send that Markdown to HTML and peek at that. Now, there have been some folks who don't really like the notebook document format, but maybe like the notebook UI, or maybe the other way around. They like the notebook document format, but don't like the notebook UI. And for those people, there have been a few projects recent projects called IPyMD and Notedown that actually write notebooks as pure Markdown and convert back and forth from notebooks to Markdown, which can improve. Markdown plays nicer with version control. You can version control notebooks just fine. We do all the time. But including output is often something that people would rather not do. And so if you strip it down and convert it to Markdown, it's a lot easier to read the diff on a Markdown file than a JSON structure. IPyMD was actually written to integrate notebooks into the OReilly Atlas publishing platform. And Notedown is a similar conversion between Markdown and notebooks, and specifically our Markdown. So Jupyter Hub, this is, I think should hook me up to a Jupyter Hub instance that's on the web. So the way Jupyter Hub works, I'm just going to the same presentation, just I'm on a different machine. So the notebook, that's much too large. With the notebook, you've got the browser, connects over WebSockets for execution, and then the notebook server relays that execution to kernels over ZeroMQ. What Jupyter Hub does, make it bigger again, is just add a proxy in front of that, and this hub process that manages authentication and spawning single user servers. So now I can have a bunch of notebook servers for different users on one machine or one collection of machines, all managed under one endpoint. So rather than the usual, localhost 8888, now I'm on user min RK, and that's me. And I can this added button up here for the control panel, I can see, I can start my server, I can stop my server, and I can also look at the admin panel for all the other users on this system. And this is just a hub instance we use for demos. And what this particular version is using is GitHub for login. So actually, if I log out, I can sign in with GitHub. And that actually talked to GitHub with OAuth and logged me in. With Jupyter Hub, because we know there's lots of different ways that people want to authenticate their users, and there's lots of different ways that people want to allocate resources for their notebook servers. So those two aspects of Jupyter Hub are very simple interfaces that are modular. So Jupyter Hub just ships with PAM authentication and local process spawning for kind of real users on a Unix system. But we've also written a GitHub OAuth and Docker spawners and spawning with EC2 and PBS and a variety of mechanisms for starting the spawners in a variety of contexts, whether isolated or not, and authenticating the users with a variety of services. And these are very simple interfaces that are easy to kind of write your own version. That I've got my auth over here. I can write an authenticator and drop it into Jupyter Hub and be off and running. I just want to do a quick demo of using Jupyter and IPython with Spark. So one of the things we get in the data science domain, we get a lot of people who want to use Spark, who've either heard about Spark as the new hotness, and they are like, all right, how do I get to use Spark? Either they really want to use Scala or they really don't want to use Scala. You get some of each. And there are some projects that have certain things in common with Jupyter, but among the main advantages that they present is their integration with Spark. And to us, that is we don't feel like we don't integrate with Spark that much, and part of that is because we view Spark as just another library. And so you can just import Spark. The one weird thing about PySpark is that you don't install PySpark. PySpark sits next to Spark. But if you know where Spark is, all you need to do is tell Python, this is where Spark is. And then you can, let's do this only once. I had already done that. You just import PySpark and then make a context. And I'm just running locally on my laptop because I don't always trust networks when giving talks. But so I have my Spark context, just using PySpark as a library in a regular Python Jupyter notebook. Load some data with NLTK. In this case, I'm just grabbing Project Gutenberg data. And I can create a Spark RDD. That was what I wanted to avoid. So I've got my Spark RDD representing these text files. I can perform operations to gather, to sort to find the most common words and then sort them by their frequency. And if you're familiar with Spark, doing all these operations is actually just building a computation graph, and Spark doesn't evaluate the graph until you actually ask for a result. So writing the code to actually do all that computation finished very quickly, but then when I actually ask for show me the top 10, it actually submits and computes that graph, which takes a little bit more time. And then I can also, write custom functions. I can just load my dictionary from disk, and then I can count some vowels, and then just do a simple plot of the results of that. Counting the words so this is just counting for all the words in my dictionary, I count how many vowels are in that word, and I can just see the frequency of, all right, most words in English anyway have either 3 or 4 vowels in them, and it falls off as you move away from that. Just a simple toy result. Another good example of Spark in Python in Jupyter is a project called Code Neuro. Code Neuro is a neuroscience project for doing things with primarily neuroimaging data. And they have some demos. This is actually a custom deployment of TempNB for those. I meant to do demo. So if you visit if you want to check out notebooks, especially notebooks in languages other than Python, you can go to try.jupyter.org, and it will spin up a notebook server for you. And then you can start playing with Haskell or R or Julia. And I can, these are the kernels we currently ship on Try Jupyter. So we got Python 2, Python 3, Julia, R, Ruby, Bash, and Haskell. So if you want to play with any of those languages, you can hit Try Jupyter. And this is what we do. This service is, Try Jupyter is just one instance of TempNB. A probably more interesting instance of TempNB that I've now lost is Code Neuro, which instead of our simple demo images that just have a few example notebooks for playing around with these kernels, Code Neuro actually has a bunch of neuroscience data, and the Docker containers actually are hooked up to a substantial Spark cluster. So you can play around. Theirs takes a bit more time to load. You can hook up. So this just spawned a notebook server just for me on their hardware. This is a TempNB instance. Boy. And I can poke around and this is using something called Thunder, which is a data analysis a tool built on top of Spark. And you can see the images are in fact just in a PySpark context. I don't know if you can see that. So this is just a collection of like 30 gigabytes of neuroimaging data that for mouse brain measurements, and it's loaded into a Spark data set on Hadoop, and then the expensive step is actually loading that data from S3, which is running right now. And we can step through and do these visualizations and plots of several tens of gigabytes of neuroimaging data, just in a little notebook hooked up to a Spark cluster. It's that initial load that takes a while. And I encourage you to, if you're interested in doing Spark with Python, I encourage you to check out Thunder and what they're doing on Code Neuro, which is a really nice kind of wrapper around the low-level Spark operations. Yeah, there we go. Yeah, so I can peek at my mouse brain, which I do not understand what these things are. I know these are activations of, these are showing brain activity during some whisker simulation in a mouse, but you got some nice seaborn plots that I think I skipped. No, I didn't. And then we've got tools like MPLD3 and Bokeh and Lightning. So Thunder, which is a data analysis pipeline, has a counterpart, Lightning, which is a data visualization tool for building nice interactive graphics with Java, your standard JavaScript plotting libraries. Yeah, and I think so. That was about an hour-ish. Yeah, I have more things I can play with, but I'd maybe rather do what people are interested in hearing at this point. Yeah.
Any questions? Yeah.
Is it working on the collaborative coding right now?
Yes. So we have a postdoc, Matthias Buissonnier, at Berkeley, where it is his the primary topic of his postdoc. His primary task is to work on the live collaboration stuff. We have a few refactoring things that are in his way, but he is actively working on that every day.
What is the project?
The real-time stuff is kind of scattered throughout things he's mostly working on various branches of the notebook repo and of the Jupyter Drive, which is the Jupyter notebook backed by Google Drive.
I actually got a few questions of my own. So actually, we invited Jerry Freeman to give a talk a few months back on this Neuro and all the Lightning projects. So my question is, I noticed there's also support for Scala, so the interactive using Scala to talk to. So that's not one of your TempDB.
That was not one of the ones we put on TempNB, mainly because people haven't asked for it.
I know the IBM have Spark kernels.
Yes, IBM has a Spark kernel. So it is great that IBM has the Spark kernel. From the Python and PySpark perspective, I'm not entirely sure why there would be a Spark kernel, because at least from the Python standpoint, Spark's not a kernel, it's not an environment, it's just a library. So you would have either a Scala kernel and you load Spark, or you have a Python kernel and you load PySpark. But yeah, there are, so IBM has provided a Spark kernel that actually integrates Spark more deeply, and I think it's basically Scala with Spark imported, essentially.
Yeah, it's calling Spark repos directly there.
Yeah.
So the other question is, you follow the one with the Scala interactive stuff. Is there in the projects already? There's somebody using?
Yeah. Yeah, so you can check out the index of kernels for Jupyter. Scala is actually one of the earlier ones. It is not an active project. Yeah, let's see if there's any examples. Yeah, unless you'll just render and get up. So this is a notebook running with a Scala notebook. I don't have the Scala kernel installed on my machine, but
that's cool. 2 more short questions, and I'll give to the audience. Sorry, please. One is you said it's anybody who implement the protocols you define and can basically interact with the kernel itself. How difficult to implement that?
So the C++ kernel, I wrote in about an hour. Part of that. That's maybe not the best example, because it depends on the nature of the language. So for languages that already have a REPL, Bash, R used to be this way. The Python, you can actually reuse the Python implementation of the message spec, and then use a library called PTY-Python. You wrap a REPL, and then you just kind of get the message spec for free. And that's what I did for C++. I did that. I wrapped the Cling C++ REPL in the Python wrapper kernel machinery. To do a native kernel, the Ruby kernel was written by someone who is not especially familiar with either Ruby or Python, and he did it in a weekend. So it's if your language has ZeroMQ bindings, which is most languages, then it's not a lot of work. The rich display stuff is the coming up with an API that makes sense in your language for rich display is maybe one of the harder parts. And in some languages, so we get plotting in the notebook with matplotlib, and it really depends how easy it is to capture plots from whatever popular plotting library you have. In some languages, the plotting libraries make that really, really easy. Matplotlib's one of them. In some languages, it's significantly less easy. MATLAB is one of those. So for getting simple input and standard out, standard error is usually not a lot of work. For providing library APIs for the rich display can be more work, and that depends kind of on what's already available to you in the language for capturing it.
I see. My last question. So you have this kernel, and multiple applications can talk to it, and for a single data scientist and play, that's cool. But what if you're put on a cloud service and there's a lot of the concurrent users and a lot of application hitting it? So how scalable is the kernel?
So normally there is one kernel per notebook. So I've got one notebook, and then when I open a new notebook, that other notebook, it's a different kernel. So, and in the default circumstances, that's another thing that's technically pluggable, is how the notebook server spawns its kernels. Unlike Jupyter Hub, it's relatively uncommon to modify that, but it's still possible. That since we talk to it over ZeroMQ, which is just a network interface, the fact that we do it by default over localhost is just an implementation detail. So you could actually, when you open a notebook and ask for a kernel, that kernel could be getting its own Docker container or entire EC2 instance, or maybe one slot on, you're doing some elastic scaling, or that you're allocating new hardware and or new compute resources, and you're assigning kernels to those. So it's really one kernel per notebook, and you can distribute that on as much hardware as you need.
Thank you.
Great talk, thank you. I have a question about interactive visualizations. Mm-hmm. So I know there are a few visualization libraries, but the thing that I don't really understand is when you pop up an interactive visualization within a notebook, and then the user interacts with that, mm-hmm. It seems like the state that results from the user interaction gets lost. Is there any way to keep that state, or have the interaction generate a new entry in the notebook?
Yes. So it depends a little bit on how the interactivity is accomplished.
Let's say brushing, for example. You brush a region on a scatter plot, and you want to save that as part of the notebook. Yeah.
So there's two ways to do that. One is if you're using the widget infrastructure. So in IPython, there's kind of 2.5 ways to accomplish interactive graphics. One is you put HTML and JavaScript on the page, and whatever that can do, that can do.
But then you lose the state.
But as far as IPython, when you do that, as far as IPython is concerned, you put static HTML on the page.
Yeah.
And we don't track that. Now, there is a solution that we've been thinking about for a while, and that's have like a freeze functionality, like maybe to capture the current state of output. Say, assume this output could have changed, so replace the one that we stored in the document structure with what's currently on the page. And it might make sense to actually do that by default. It might make sense to only do that on explicit request. That would actually be really easy. I've been meaning to do that for a while, but I have a lot of other things to do. So that's the answer to the generic case.
And you mentioned the widget interface. How could that play in?
So the widgets, when I move the slider and do things to change what the widget does, that actually triggers events that essentially the UI knows about. So with something like that, you can actually, it's more likely that it can actually tell, okay, something changed, and that something is some. So when I, for instance, when I'm moving the slider for the factorization example, those are actually regular outputs. So when I move that, those are new outputs. And so the most recent one is actually what's saved in that case. So that's what I meant when I said it depends on how the changes are happening. And you can also, in your JavaScript, you could, so like I said, we could add this freeze functionality to kind of freeze all outputs. You could, in your JavaScript, actually do, when I change, actually clobber my output in the document with my current self. So you could solve that problem if we're too slow. You can actually solve that problem in your own output. You can have the dynamic JavaScript that you're executing on Paint or whatever. So you can actually have that talk to the JavaScript of the notebook and say, find my output, and actually replace the output in the document structure.
I see.
Replace the HTML
That's
with
what I was
me.
looking for. Because imagine if you have a map, a geographic map, and then you zoom into a particular place, and you want to have that place zoomed into later on when somebody else opens up the notebook. That's how you could do it?
Yeah, that's one way you could do it. The other is you could append new outputs.
Append a new one. Okay,
yeah,
cool. Thank you.
Yeah, so right now I would guess it's kind of tricky to find yourself.
It's always tricky.
If I am this output and I want to find where the HTML that created me is in the document structure and remove that and replace it with the current state. What's probably the trickiest part of that is finding it. You can.
But it should be possible somewhere.
Yeah, but that should be possible. What would probably be easier is to append new outputs that say kind of update the state.
Right. Thank you.
Mm-hmm.
Anybody else?
About version control for what are the tools we have to manage? Is it Git? Because with IPython notebook, it's difficult to track what are the changes through Git, but I don't know what are the tools we have for this one.
Yeah, there's a kind of a stalled project called NBDiff that we're planning to pick up and polish for better diffing of notebooks. The other things you can do are you can view diffs of, for instance, most of the time you actually only care about input, diffing the input. The outputs may have changed, but you don't actually care about looking at how the outputs changed. In that case, you can actually compare. You can pass the notebooks through conversion to Markdown or something, and then actually diff the Markdown, and that's easier to read. There are kind of steps involved, but that's kind of either kind of a GUI diff of notebooks is one way, and that's what NBDiff is. It needs a bit of help, and then there's diffing through kind of lighter, stripping away the JSON and diffing in a plain text format via NBConvert is another way. It doesn't, when you do that one, you don't get merged because you're throwing away a bunch of information, but it lets you at least read and review the diff.
Okay. Sure.
Thank you. Notebooks are awesome. Use them all the time. So thank you for your work on this. I have two questions. First, I was wondering, are your notebook available for us to review later? Is it?
Yeah, it's on. Sorry, I should have made that clear. It's the most recent repo created by Min Ragan-Kelley, and it's got an obvious name.
That's good.
Yeah.
Great. My other question, you talked about separating the kernel from the UI, and how you can do this in Docker, do this in various ways. I've been using notebooks a lot on my own, local machine. Mm-hmm. But if I have things going on in the cloud, or I have a cluster set up, or EMR or something, is there a way of kind of neatly integrating those without, where you can, have results or work in your notebook on your local machine, but then have computation being done remotely?
There's a couple of ways. One way to do that, so do you want your kernel, like all the code, to be remote? Or do you want to be, do you want code in your notebook to be running locally, but then also be connecting to the remote?
Either one's fine.
Okay. The easier one, which may not be obvious, is actually having the local notebook with the local kernel, but then talk to the remote thing with. We have there's an IPython project called IPython Parallel, which is actually where I started in IPython. So my undergrad thesis was the first version of IPython Parallel, which lets you run IPython instances, a number of IPython instances on EC2 or what have you, and then talk to those from a client interface. So in that case, you've got your kernel on your laptop, and then a client API for running code on the remote or parallel cloud resources. And in that case, and it's talking actually the same message protocol that the browser is talking to the kernel is talking to other kernels. So we've got basically a Python client API for talking to other kernels. And there are things like, do you know about Star Cluster? The Star Cluster is a tool, it's an API around the EC2 API to make it nicer. So you can do Star Cluster start, and it installs like the scientific Python stack and sets up NFS and security groups and everything. So you just say, I want this AMI, this and this instance type, and then it sets up everything else for you, and this many nodes. It sets up everything else for you. And one of the things it can do is spin up an IPython cluster, which is what we call the IPython parallel stuff. And then you can just connect clients from your local laptop. I don't know if you use notebooks, you may have seen, look, there's the clusters tab, and I can start that. So there's that, and you can actually make that start things on EC2, just clicking that button.
Sort of related to that, if you're interested in doing computation that needs a GPU, what's the best way to do that?
So I don't do a lot of GPU stuff, but there are a variety of tools. And of course, it depends on your language of choice. I mostly talked about Python because I mostly work in Python. In the domain of Python, there are tools like Numba. Numba has some GPU acceleration support. Theano also does GPU work. There are lower level things like PyCUDA. So they're in the domain of kind of high performance PDE stuff. There's a lot of GPU acceleration going on, and a lot of Python libraries using GPUs for that. Andreas Klockner has a few tools for working with OpenCL and CUDA APIs from Python. And then there are a few code generation tools that actually generate CUDA and OpenCL code. And Numba is one of those via LLVM. And I know there are others, but I can't think of them off the top of my head. But there are a few. There's definitely not an obvious winner right now. There's not like, this is what you should use for GPUs from Python. There are a variety of competitors right now. Yeah.
I'm just curious. What is your impression of the Zeppelin project? It seems like it's kind of recreating IPython Notebook.
Yeah, I kind of alluded to it without mentioning it. Yeah, it's reinventing a lot of what we've done, but taking out, kind of the reusable portable document format and taking out the language agnostic parts and taking out a lot of what we find interesting about what we're doing. they've been successful in targeting a lot of people with, Spark being the new hotness, the fact that they are really all about Spark. We've actually talked to a number of people where they're like, Jupyter is cool, but we want to use Spark, and Zeppelin supports Spark, so let's try Zeppelin. And it's like, but there's plenty of people using Spark with Jupyter. I don't understand. But we don't talk about it. Like you can't find, if you look at our documentation or anything, Spark will not be mentioned, and that's something that we're working on. So yeah, I don't know. I mean, if they don't like what we're doing and they can do it better, that's fine. They're welcome to do that. But yeah.
So just for a newbie's understanding,
yeah.
Is there ever a reason to use IPython over Jupyter? Since they're basically one and the same and Jupyter grew out of IPython, will they continue to move in unison or do separate things?
Yeah, this is something that I didn't make clear and we struggle to make clear. They're really the same thing. So right now they're really the same thing. The pieces of IPython that are language agnostic, like the notebook, NB-convert, the NB format, the protocol, are moving to Jupyter. And IPython will kind of shrink to being the Python kernel for Jupyter. So it's really just it's really the same thing. It's just, in IPython 3 is the last monolithic release. So we released IPython 3 in March. And it's the last release where everything's in one package. And then for 4.0, we're actually going to have several packages that you pip install notebook. And that's going to be the Jupyter notebook. And then IPython is the kernel for the Jupyter notebook. And those are separate packages. So there won't be a choice IPython or Jupyter. It'll be, I'm using Jupyter because I want to use the notebook. If I want to work in Python, I'm using IPython. If I want to work in Scala, I'm using iScala. If I'm working in Julia, I'm using iJulia. So you use IPython as opposed to iScala, but you're using Jupyter if you're using the notebook.
So there's times where I'm working on a IPython notebook and it's kind of exploratory and sort of for myself, and then it's time to kind of turn it to the rest of the organization. And I haven't found anything like Shiny or something where, what is the best way to kind of just simply turn it to the outside world?
I wouldn't say that there are too many tools to really do that. If you want to make, HTML and stuff and publish that, that's going to be NB-convert is going to do that for you. I think with things like IPyMD and Notown, I think there are probably going to be some people working on wrappers of NB-convert to build. So NB-convert is kind of basic, but extremely extensible. And so I think there are going to be some folks for building kind of much nicer, very specific exports of notebooks. But those aren't really around yet. So it's more doing stuff yourself at this point. In terms of cleaning it up, that's mostly done kind of by hand at this point. You can use metadata on the notebooks to kind of mark this is scratch stuff, and then you can do an NB-convert pass that just filters out, takes all these cells and hides them or throws them away or something like that, that you can mark cells that should be included in the export or not. That's something NB-convert can do. Keeping interactivity actually depends on, so we've got another project for what we're calling somewhat confusingly static widgets, which is to say it's widgets where a static export of the widgets includes all the information to preserve interactivity. And we actually have a fully working, it has been fully implemented. It's just the storage of the states and stuff that we don't quite like yet. So we've been working on that on and off for for a while. And it depends a couple of things. So for IPython widgets, there will be a way with NB-convert to basically compute, to kind of scan through the values of the widgets and compute those and store all those outputs so that you can scroll through the widgets without a kernel and get new outputs. For some plotting libraries like Bokeh and Lightning and Plotly, the plot themselves is actually an interactive HTML thing. And so the thing that's in the notebook actually is itself interactive. And if you're using those libraries, they're just as interactive on NB Viewer as they are in the live notebook, because the interactivity is provided not by interaction with the kernel, but by HTML and JavaScript, and sometimes interacting with a separate plotting server. So like today, the answer for that is to use those libraries. There's also a way to get Matplotlib animations and some things like that.
I think that'll be the last question. Thank you so much, Min. It's a great talk. Okay, that's it. Thank you very much for coming.